This is the third year group elements. The third year group elements are already we know that boron, aluminum, gallium, indium, thallium. If your group means just first you have to remember what is the element's name. And also you remember that it is the fifth element in the periodic table. This is the fifth element. And come down to this next one you want means add 8, you're getting of 13. Next add 18, that means it is nothing but 31. Again you are add 18, it is nothing but 49. Next add 32, you're getting of this is a 81. Okay, this is the formula to write the electronic configuration for both purpose. This is the indication we are click. Now, in the third year group elements, these are the boron, aluminum, gallium, indium, thallium. Write the electronic configuration. First, I am writing the electronic configuration. This is the first property I am showing because on this first property, you have so many number of questions, you can frame it. So, I am writing the electronic configuration. So, boron is the electronic configuration is 1s2, 2s2, 2p1. And also, I am writing here only the short form. The short form of the electronic configuration 1s2 means it is a helium. Why you are writing the short form? That is the zero group elements, that elements representation, and the valency electron. These are the valency electrons. The valency electrons are present in the second group. This is the second group. Number of electrons are 3 are there. Similar manner, write the aluminum also completely. You are writing 1s2, 2s2, 2p6, 3s2, 3p1. So it is nothing but nearest electronic, that is the neon, is the 10th atom in the periodic table. So 10 electrons are over. Remaining 3 electrons are belongs to 3s2, 3p1. Similar manner, gallium, it is the 31. If you are having the patience, you write down. Otherwise, no need of this one. Just write the short form of the electronic configuration. After the helium, neon, argon. Argon is the 18th element in the periodic table. So 3d10, 4s2, 4p1. This is the valency electrons. Similar manner, indium. We are writing after helium, neon, argon, krypton. So krypton is there. So the krypton here we are getting of the 4d10. 4d10. After the 4d10, you are getting of 5s2. So 4d10, 5s2, 5p1. This is the electronic configuration of indium. In a similar manner, argon, krypton, you are having of the next element in the zero group element is xenon. Here we are getting of the 4f14, 5d14, 6s2, 6p1. Valency electrons are, these are the valency electrons. Valency electrons. Keep in mind, this is a way of writing of the right electronic configuration. Okay, ma. You have clarity about this one. So on the basis, you can fill a number of questions. First, remembering of the elements name. The third year group elements are boron, aluminum, gallium, indium, thallium. Next is you have to identify the atomic number. Next, you have to write the electronic configuration. First 2 elements, you have to write the elaborately. Next 3 elements, no need of that one. Just write the short form of that one. Now you can conclude it as from this one. This particular third year group elements are belongs to. First question I'm writing. Third year group elements are belongs to P block elements. These are P block elements. Why it is called as P block elements? Because the last electron is entered into the P only. 2p, 3p, 4p, 5p, 6p. That's why the third year group elements are called as P block elements. The next question is the common oxidation state, or you can first write the general electronic configuration. Already you are written the electronic configuration. GEC means general electronic configuration is NS2, NP1. So these are the important points in the examination point of view. General electronic configuration. Next is common oxidation state. Common oxidation state. The common oxidation state means this particular element or atom can easily lose the 3 electrons. One electron is from the p orbital, 2 electrons from the s orbital. So it is losing. The common oxidation state is +3. Okay. See, we are writing off from the electronic configuration. These are obtained from that one. We are getting off in this one. So the common oxidation state is over. Then after the common oxidation state, we are having of the this element coming to the all the elements which are present in the boron, aluminum, gallium, indium, the thallium. Boron. Next is the chance is boron is you are having of the non-metal. This is the non-metal boron. Remaining other, that means aluminum 2, thallium is metals. These are the metals. You have to remember. There are chance of asking of the question is only except boron. Remaining other elements are metallic character and boron is in non-metallic state. Okay. So that is non-metallic state is present in the boron. So these are the important. Next coming to the already told that the important minerals of the some of the elements are they are asking. So always remember in any group, the 2 elements are very important. In the 2 elements, the boron and aluminum. So boron, what are the important minerals? Boron important minerals are. Already I told that the boron important minerals is only one is there, that is borax. Borax is the important mineral of boron. The formula there are Na2B4O7 10H2O. This is called as borax. Okay, ma. Borax formula you have to remember Na2B4O7 10H2O. The crude form of the borax, the crude form is called as tinkal. Remember, this is a very important. Coming to the next one, that means you have to showing up the after the boron. Okay. Next is the aluminum. Aluminum important minerals are important minerals. This I am writing the aluminum important minerals here. Only I am written that one. Aluminum important mineral is bauxite. That is Al2O3 2H2O. Okay. Next is the cryolite. Next is the fluorspar. That is the feldspar is there. So next second one is the cryolite. We have to remember all the elements compulsory with the formulas. Formulas are very important here. So these are the cryolite. And third one is feldspar. These are the element. So cryolite is a sodium aluminate. That is Na3AlF6. Na3AlF6 is called as cryolite. It is potassium, but we are having aluminum silicate. Feldspar is called as potassium aluminum silicate. Potassium KAlSi3O8. Potassium aluminum silicate is called as a feldspar. These are the important topics which are present in this particularly third year group element. So these are every point is important in our examination point of view. 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 questions, minimum 2-3 questions will appear every time. So these are the only the question that's asking in the examination point of view under the third year group elements. Now we will be discussing in detail of the third year group elements of particularly hydrides and oxides. Okay. First we are discussing about the hydrides. Then I will go to the oxides. What are the hydrides are possible? What are the oxides? Mainly important of the boron hydrides and aluminum hydrides, and boron oxides and aluminum oxides. Okay. So we will discuss about the. I will just raise this one. So anybody want to that one take the screenshot? Better, easily to watch anytime. Particularly these elements, but particularly formulas are very important in this point of view. So keep in mind that one. Now we are discussing about the hydrides. Hydrides of boron. Actually, the hydrides means it is the unit of BH3. This is called as a hydride. But the boron is forming of two types of hydrates. Already I told that is BN HN plus 4 type and BN HN plus 6 type of hydrates. These are the boron hydrates. So BnHn plus 2. Suppose n is equal to 2 if you are keeping of that one. It is nothing but B2S6. This is called as diborane. The example of boron hydride is diborane. Suppose you are keeping of the 4. N is equal to 4 means P4H10. B4H10. Tetraborane. This is the tetraborane. So many number of boranes are possible. So hydrates of the boron, these are the important mainly important is the diborane is the important one. Why the diborane is because I already told that it is the electron deficient compound. This electron deficient compound diborane is as a specific indication is there. These hydrates are very useful. How to prepare that with you, we'll discuss later. Only hydrates we are discussing. These particularly boron hydrates are discussing. That means we are discussing about this one. If we are same hydrates of the aluminum, suppose we can using of the hydrates of the aluminum. So hydrates of the aluminums are aluminum hydride, AlH3. This is a type of. Here this is a type. See in this case, boron hydride, the 2 units is nothing but the diborane. 2 units means multiply with the 2, B2S6. This is the diborane. Here aluminum hydride will be getting off this one only. AlH3. These are the type of hydrates are formed by the boron as well as the aluminum. How can you prepare this boron this particularly preparation already there? Suppose if we are taking up the boron chloride with the lithium aluminate. Boron chloride with the lithium aluminate is reacted. Lithium aluminate is the reducing agent. You can getting up the simple boron, that is a diborane. Here also aluminum hydride will also keeping up that one. Aluminum chloride is treated with the lithium aluminate. Aluminum chloride is treated with the lithium aluminate. We are getting off aluminum hydride. That is the one. But in the examination, they want us what is the hydrates? Hydrates are the boron hydrates are there. These are the 2 types of boron hydrates are there. BnHn plus 4, BnHn plus 6 type of hydrates are there. Both are there. But these boron BnHn plus 4 diborane is the most stable compared to the remaining other diboranes. These are the stable hydrates. Okay. Next, coming to the oxides. Boron can form oxides, the boron trioxide. When the boron is treated with the oxygen, you are getting off boron trioxide, B2O3. Similar manner, aluminum also, when you are combustion, you are getting off aluminum trioxide, Al2O3. This is a boron trioxide. This is nothing but boron trioxide. That means trioxides are formed. Mainly important, you are seeing of this one. Oxides, we are getting of the trioxides, we are getting. These trioxides are very useful. In this case, this boron trioxide, you can easily getting of this one. Here already I told that the boron diborane preparation will be, I can again repeated the preparation, but in this case diborane, when you are using of the hydrolyzed, this diborane on hydrolysis, you will be getting of boric acid, the property will be there. So here also from the boric acid on thermal decomposition, boron trioxides are prepared. So there is, don't worry about the examination point of view. This is important is the only from the oxides. From this is the hydrates and oxides. What type of hydrates, what type of oxides are formed by the boron and aluminum? Boron can form the boron trioxide. There is a hydrates BH3 type. Aluminum can form the AlH3 type. Here oxides are boron trioxide, aluminum trioxide, gallium trioxide, indium trioxide, like that everything. So in this, the examination point of view, they will ask boron trioxide, that means B2O3 is acidic in nature. Aluminum trioxide, Al2O3, and gallium, Ga2O3 is amphoteric in nature. Amphoteric means they can act as acid as well as the basic in nature. After the boron, aluminum, gallium, indium trioxide as well as the thallium trioxide. These are all basic in nature. Please keep in mind these important points in the oxides. So oxides, there is a chance of getting up the questions are, what is the nature of the boron trioxide? What is the nature of aluminum trioxide? What is the nature of gallium trioxide? That's all. Mostly, they will concentrate boron and aluminum, not other elements. Why? Because I'm writing all the elements. Okay. So oxides of this particular 30A group element, boron trioxide is acidic in nature, but aluminum trioxide is amphoteric nature. Please keep in mind that is the important one. Now, next is these are the important properties of the hydrides and oxides. Coming to according to the examination point of view, electron deficient compound. What is the meaning of electron deficient compound? So electron deficient compound means actually a compound is formed means because of the sharing of the electron between the two atoms. So a bond is formed. That bond is a covalent bond. That bond is a very strong bond. Then only the bond is formation. So compound is existing. If you see the ethane formula is CH6. Here the ethane, the structural formula, if you see that one, this is the between the bond and bond. That means carbon atom 1 electron. This carbon atom 1 electron. You mutually sharing this one. A bond is formed. Similar manner, I'm writing this one means it is nothing but this electron, and this means I'm writing the electron. The 4 electrons are present on each carbon atom. These electrons. 4 carbon atoms, these electrons are present in each carbon atom. And 1 electron belongs to that means hydrogen. So the hydrogen.
Support full the contingent level.
4 contingent level, right. Okay, beta?
Okay.
Okay, ma? Right. Now, so C2H6 formation means each carbon atom is having of the 4 electrons. This carbon atom is having the 4 electron. Each hydrogen atom is having 1 electron. That means it is nothing but hydrogen is nothing but 1s1. Carbon is nothing but 6th element. That means 1s2, 2s2. Okay. 2px1, 2py1. Here the electron is jumped into the 2pz. 4 unpaired electrons are there. Here 1 pair unpaired. So each carbon is having a 4 unpaired electron. Each hydrogen is having a 1 unpaired electron. So that ethane molecule structure is formed. That means it indicates as in this ethane molecule, how many number of electrons are there? 1. This is a pair. 1 pair, 2 pair, 3 pair, 4 pair, 5, 6, 7 pair. So total electrons are 14 electrons. Right, Amma? Here the 14 electrons are present in India. That's why ethane is a strong molecule. It is a stable molecule undergoing of sp3 hybridization. And the making of the bond angle is 109 degrees 28. Similar manner, our boron hydrate, that means diborane, B2S6. See the formula. You believe that it is also a similar formula. C2S6, it is a B2S6, nothing but. But the boron, if you see the boron, it is the 5th element in the periodic table. So 1s2, 2s2, 2p1. Suppose this electron is jumped into the Z type. That means it is electron is jumped into this one. You are getting up. How many electrons are there? 3 single paired electrons. So each boron atom is having of 3 single paired electrons. But each carbon is having of 4 electrons are there. It is not there. Similar manner in the diboron. One more boron is there. It is also having of. And each hydrogen, that means hydrogen is 1s1. Means 1 electron. It is 1 hydrogen. Suppose if you taking off 1 hydrogen. Here, I'm writing here. Okay. Why? Because here hydrogen. I'm keeping up this one hydrogen. It is empty. It is a not paired one. But here the pairing is between the boron and boron. What about these hydrogens? There is no, or that means paired electron is there. It is a single electron. That means the central atom, this is central atom. If you see central atom, Here the carbon C, the central atom. How many? 2. This means that these are the 2 electrons. This means 2, 2, 2, 4, 8 electrons are there in the central atom. But here 2, 4, 6, 7 electrons only. 1 electron is deficient. Here also 7 electrons only. That means the total electrons are 12 electrons only present instead of 14 electrons. That's why this is the diborane is called as electron deficient compound. Electron, what is electron deficient compound in the examination? They'll ask, what is the meaning of the electron deficient? The compound in which the number of valency electrons of the central atom is less than the stable valency electrons. Are you following that one? What do you mean by the electron deficient compound? Means the compound in which the number of valency electrons of the central atom is less than the stable valency electrons is called as electron deficient compound. Example is diborane is electron deficient compound. Why? Because this diborane is required of 14 electrons, but this is diborane is consisting of only 12 electrons. 2 electrons are lesser than the stable electronic configuration, stable valency electrons. That's why the diborane is called as electron deficient compound. Now this diborane is how to prepare the diborane in your examination point of view. Write the preparation of the diborane. So, preparation of diborane. Simple, we are having of 3 type of preparations are there. For first is the with the help of the boron trifluoride with the lithium aluminate. Next is the boron trichloride with the lithium aluminate. Next is the boron trichloride with the hydrogenation. That means thermal electric discharge tube. You can usually, that is the preparation will be takes place. First, we are having the first preparation. Boron trifluoride. Boron trifluoride. See, this is a boron trifluoride. Very simple one. We are using of this one. Boron trifluoride is reacted with the lithium hydride. When boron trifluoride is reacted with the lithium hydride, formation of boron diborane and lithium fluoride. Very simple. That means we have to simply, this is a multiply with this one, 3, 6, 1. Okay. Now 2. Balancing purpose. Here we are getting out 6. First preparation. Boron trifluoride is reacted with the lithium hydride, formation of diborane. Okay. And second preparation. I'm using of similar way. Instead of boron trifluoride, I'm using the boron trichloride. Boron trichloride is reacted with the lithium aluminate. Just now I told in the boron oxide hydrides. Boron trichloride is reacted with the lithium. This is a dehydrating agent. Okay. So reducing agent. This is a reducing agent. Lithium aluminate is a reducing agent. Formation of diborane. Okay. Diborane, lithium chloride, and also aluminum chloride. The byproducts are formed. Okay. So if you are multiplying with this one, you are getting off those elements. Boron. These are the elements which are having of that one. Lithium aluminate. You are getting off boron hydride. And third one, same boron trichloride is reacted with the electric discharge tube that will be you are using. That means here this particular boron trichloride vapors are passed into the electric discharge tube. That is in the hydrogenation formation. Silent electric discharge tube. We are using of the silent electric discharge tube. Okay. So we are getting off diborane and HCl is formed. Okay, this is about the 3 only preparations are there. It is a essay type question in the examination. Write the preparation. What they ask, what is electron deficient compound? Give the example and write the preparation of diborane. What is the electron deficient compound? The compound which is having of the less number of electrons that for the central atom than the stable valency electrons. That compound is called as electron deficient compound. Example is the diborane is the electron diffusion compound. Why? Because diborane is consisting of 2 electrons, but it required 14 electrons. So it is 2 electrons are lesser these there, but it is a stable one. Diborane is a stable one. So we are getting of the preparations. These are about the preparations of the diborane. Coming to the properties. Here only I can write the properties as well as, okay, in the examination point of view, they ask the preparation as well as the properties. So easily first is simple thermal decomposition. So combustion will be take place. When the combustion means burning in presence of oxygen. When the borons are burning in the presence of oxygen, diborane is burning. That means the first preparation combustion. Diborane on the combustion, you are getting of boron trioxides. Simple, already you are prepared. That is boron trioxides, and the liberation of the water molecule, some amount of energy will be released. It is an exothermic reaction. Boron on combustion, we are getting of boron trioxides. Second property, this is a very important property. Second property, hydrolysis. Already told that hydrolysis. What is hydrolysis? When the diborane means B2S6 unhydrolyzed H2O, you are getting of boric acid H3BO3. This is called as boric acid. Very important formula. Examination point of view. Write the formula of boric acid. H3BO3 is called as boric acid, and hydrogens are eliminated. The gas of hydrogen is evolved. So what is the formula of boric acid? You have to remember this one, important. Okay. Now third one is a very important. I can keep on the top or here only. You can visible na third. Okay. Now this is a, that means why diborane is treated with the ammonia, means at the low temperature reacts with the ammonia. That means it is reacts with the ammonia. How the reactions occur? See, ammonia, I am using of the three properties, very important properties. Is diborane B2S6 is reacted with the ammonia at low temperature. When you are eating of low temperature, formation of B3N3H6. B3N3H6. What is that one? Already yesterday I told that B3N3H6 is called as borozole. Borozole. This is very important, and elimination of hydrogen molecule. This is very important for your examination point of view. What is the formula of borozole? B3N3H6 is called as borozole. So how it is formed? When the diborane is treated with the ammonia at low temperature, borozole is formed. What is the structure of the borozole? Borozole is a similar structure of the benzene structure. I can write on the top, that is a borozole structure. So, say this is the alternative single bond, double bond, single bond, double bond, single bond, double bond. Okay. On this, you are having of the similar structure of hexagonal ring structure of the benzene. Similar way here also you are having of the hexagonal ring structure. This is the borozole. This is nothing but B3N3H6. See, 1, 2, 3. 3 boron elements. Nitrogen 1, 2, 3. 3 nitrogen, 3 elements. 6 hydrogens are surrounded. This is nothing but the borozole. Similar the benzene like structure, it is there. So this is about the boron. Okay. Now in the examination point of view, it is essay type question. What is What is electron deficient compound? Write the preparation of diborane and its properties. Properties important is the second, hydrolysis. When the diborane is hydrolyzed, you are getting a boric acid. When the boron hydride is reacted with the ammonia, getting of the borosol. Okay, so these are the important one. And so many number of remaining other. If you get to the of next one is a chlorination. Suppose the boron dihydride, that means diborane B2S6. Chlorination, formation of boron trichloride. We will getting off. Again, SCl is eliminated out. This is the fourth one, but it is not important one, the properties. This is a chlorination. Addition of the chlorination, you are getting of the boron trichloride. But in these two, second and third one is very important, and structure also very important in your examination point of view. Now coming to the structure of diborane. So structure of diborane, so many scientists are derived the structures. They are given a number of structural formula, but after that structure of diborane. Already just now I told that the diborane is having of the 12 electrons are there. The 12 electrons may be like this. They are having of the electrons which are present between the carbon, that means boron and the hydrogen. Where hydrogen, in between the hydrogen it is located, that is a very confusing of that one. So our scientists are believed that the boron is a similar structure of the ethane. So ethane molecule, we are having of that one ethane. The ethane is having of the 6 electrons. That means here 2 electrons, 2 electrons, 2 electrons. This is the 2 electrons. Like that. Here hydrogen is there, here hydrogen is there, here hydrogen. This is the chance of ethane-like structure. But here, what you see, the boron is having of the only single electron. That means not having of the 7 electron on this particular case. Okay. So 2, 4, 6, 7 electrons. It is not there like that ethane structure. Ethane similar, you see. So it is bonded like this. 6 hydrogens are bonded. It is between the carbon. But here the boron is not having this electron. Single all electron is there. Here single all electron. See comparison between the ethane and diborane. If you see this one. So here the confusion takes place. So many are believed that this may not be a correct structural formula. But they believe that it is a just like ethane-like structure, but boron is in this particularly. Each boron atom on the hydrogen, a single odd electron is present, not the paired electron. If the paired electron only, you are getting out the bond. This paired electron is there, so you are writing out the bond. Your paired electron means we are writing this actually, you have to write it like this. This is a bond. 2 electrons are combined means this electrons is nothing but the bond formation. You are writing about, but here we are having of this single electron. How can you bond that one? So he believed that there is a chance of in between the, particularly Pfizer is proposed the structure. Pfizer is proposed the structure like this. There is a chance of these are the electrons. These are the electrons. So 2, 4, 5. This is enough. This 2, 4, 5. This is a hydrogen. It is hydrogen. It is a hydrogen. It is hydrogen. But he believed that there is a chance of one more electron. Paired electron. See that one? 1, 2, 3, 4. 1. This is a nothing but the boron is having of this one. 1, 2, 3, 4 electrons are here. It is present. And one more electron, where it is located means the hydrogens are maybe chance of below the plane and above the plane. This is the plane. Above the plane, maybe chance is there. Below the plane also chances. But unfortunately, Pfizer structure is discarded. Why? Because it represents like this. It is nothing but a 2 bond, that means 2 electrons, 4 electrons, that is the bond is there. Here, the bonds are formed. Okay. No problem. What about this one? It is representing a plus H, and below the, above the hydrogen atoms are there. Whether it is possible or not, is it stable or not, means there is a question, big question is arises. So that the future formula is, or whatever the structural formula is discarded. Then after, they think that after the features formula only, the consideration, they formed as a bridge-like structure. The bridge-like structure means, if you see this one, the boron, when I am writing this one, this means it is the 2 electrons are there. Okay? Hydrogen, hydrogen. Now this is 2 hydrogen. Now this one, the bonds are formed. See friends, here, how many? This bond indicates 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So here you are having of the electrons. Each electron is bonded with that one. That particularly bonded is, here the 1 electron is bonded with this 1 electron is bonded. This electron is bonded here. Here the 4 electrons. Here the 2 electrons, the 6 electrons. This 6 electrons. 12 electrons. When it is a bridge type structure. That's why our structure of the diborane is bridge-like structure only, not ethane-like structure. Bridge-like structure. But ethane is a similar and not a bridge one. It is a single bond is present between the carbon and carbon. There is no bond between the boron and boron. There is a bond. Bridge type is bond is between the hydrogen. So you can think as, I'm using the writing of this one. See friends, please observe that particular structure. The bridge-like structure above the plane. Only I draw the above the plane. It is nothing but it is a banana. That's why diborane structure, not only they call it a bridge-like structure, it is a banana type structure. It is nothing but a banana type structure. The banana means you can write as a banana. When it is, see the banana, this banana is having of, here the, you are having of the, this particularly, here the hydrogen is there. Sorry. Here the boron is there. Here a hydrogen. This is a similar structure. When I am writing out like this one. So the simple manner, this is a, if you're not using this one, the boron atom is there. The boron. This is nothing but BH3 type of structure. The borane means here H is there, here H is there. This H is present in between that one. That is a bridging between the boron and boron. The hydrogen is bridges. This is according to the Fitzgerald. Even though Fitzgerald is given like this structure, but it is discarded. Why? Because a boron does not have enough double bond. If it is a double bond, it means it is unsaturated compound. But boron is not an unsaturated compound. It is a stable carbon, stable compound. So it may be chance of like that, this bridge-like structure it is getting off. So the bridge-like structure is consisting of the banana-like structure. So this is a banana-like structure. So you can write both bridge-like structure as well as banana-like structure of diborane is explained by the Fitzgerald. Okay, this is about our chapter 1. So in this chapter, we are having of the third year group elements, boron, aluminum. First electronic configuration. On the electronic configuration, we are having of plenty of the questions. Then you can discuss about the hydrides, boron hydrides, as well as the aluminum hydrides. And next we are discuss the oxides, boron oxides, aluminum oxides. Next we are discussing about the only electron deficient compound. Electron deficient compound, best example is diborane. For that diborane, you are preparing the preparation of the diborane, properties of the diborane, and also you are detailed structure. What is the structure of the diborane? Because this structure of the diborane indicates of it requiring of 14 electrons. Instead of the 14 electrons, diborane is consisting of only 2 electrons. That's why 12 electrons, it is an electron deficient compound is there. So many scientists are derived as the structures. It is maybe ethane-like structure, but it is not a ethane-like structure. Some Fitzgerald is taken as it is a double bond structure. It is also not correct, but lastly conclude as it is a bridge-like structure. It is a between the boron and boron, 2 hydrogens are bridged between. So bridge-like structures are formed. This is nothing but a banana structure. Like that, we have to explain in the examination point of view. So this is about the third A group elements, which is completed. Now we will go to the fourth A group elements. Today we will finish up the black one completely. Okay. So I'll go to a little bit because 2 more units are there in the black one. Fourth A group elements. So if you are asking me, immediately write down the whatever the elements. So fourth element is carbon. Next is silicon. Next is germanium.
Germanium.
Next is tin. And you have to remember this one. Carbon is the sixth element. Adding of 8, 14. Adding of 18 means 32. Adding of 18 means 50. Adding of 32 means 82. This is the sequence. Next is the, what is that? You have to write the electronic configuration. First property, you go that one. Whatever, if examiner asking or not asking, you first write down. You will get the some number of plenty of the questions here only. The carbon. So it is 1s2, 2s2, 2p2. Short form is helium, 2s2, 2p2. That means valence electrons are 4 in the s orbital and p orbital. Similar manner, write one more electron, that is our element, second element, completely. 1s2, 2s2, 2p6, 3s2, 3p2. It is nothing but neon, 3s2, 3p2. So, no need of, don't waste your time. After the neon, argon. After the argon, it is the 18th element. Next, 3D black elements are entered. 3D 10 over. So, after the 3D 10, 4s2, 4p2. And the tin. Tin is the 50th element in the periodic table. It is a very stable element, having the highest isotopes in the periodic table. Which element is having of highest isotopes means that is a tin, is the 50th element in the periodic table. For your remembering purpose, that is our using of that one. After argon, you can write as krypton. After the krypton also, it is a, it means 4d10. 4d10. 5s2, 5p1. 5p2. Sorry, 5p2. So how can you remember, sir? Means when the f orbital is entered, 6th orbit only. Means 6s2 if he is writing means we will write the 4f. Next we are lead. It is nothing but argon, krypton. It is xenon. Yeah. Now write 4f, 4d, 5d10, 6s2, 6p2. It's enough. If they ask the 4A group elements and add the electronic configuration, this is a 5 marks question. Now on this question, you can derive the number of questions. Which blocks this belongs to? Which block, man? 4A group elements are belongs to? P block. P blocks are. You can remember by means of writing the electronic configuration. Last electron is entered in which ball pit? Which block? P block. PV only. P block. So it is a P block. What is the general electronic configuration? GEC. What is the man here? See, 3s2, 2p2, 3s2, 4s2, 5s2, 6s2. Means it is nothing but ns. P2, P2, P2. This is increasing order. Integer. ns2, np2. What is the common oxidation state? It is 4 plus 4. Remember, this is the oxidation means it can lose the 4 electrons. It can also gain the electrons. Why, sir? The previous groups only are losing the electrons, not gaining. Why the atom will be losing or gaining the electrons? What is the necessity? The necessity is getting off stability purpose. The atom can lose or gain the electrons to getting off the stable electronic configuration. That is a octet rule. 8 electrons are which are present. If the 4 electrons are lost by this particular atom, the remaining will be in the inner shell is consisting of 8 electrons. Outermost there, that atom is more stable. Losing 4, gaining also 4. It is simultaneous. That's why the carbon is a tetravalency. What is the valency of the carbon is? Tetravalency means 4 valency are there. Valency state of the carbon is 4. It can give the 4 electrons. It can also gain the 4 electrons. Simultaneously, it is a very peculiar case in the particularly 4A group elements. This particular carbon can be giving the 4 electrons as well as the gaining of the 4 electrons. But the carbon oxidation state is the +4. So remember the carbon is tetravalency. Valency is the 4 tetravalencies. Now coming to that elementary histories. Carbon, silicon, germanium, tin and lead. If you know the carbon, silicon are the non-metals. Carbon and silicon are non-metals. Here, very important. Germanium is metalloid. And tin and lead, metals. Sima, here carbon and silicon is non-metals. You are using of non-metals means what? It is by seems to it is a hard, but you can just try it makes to the fine powder. You can make it a fine powder. Germanium is a metalloid. What do you mean by the metalloid? Metalloid means what? What do you mean by that? Just before I am asking the amphoteric nature. Amphoteric means that particular compound may act as a sometimes acidic nature, sometimes basic nature. Also, metalloid means this particular fellow sometimes act as a metal, sometimes
mixture of metal, non-metal.
That is called as a metalloid. Please remember. So germanium is very dangerous. Why? Because germanium is used in the semiconductors. This germanium is a very important metal. Now today you are using the mobiles. The chips are made up with the semiconductors only. That is nothing but germanium is present. That is called as a metalloid. So, but tin and lead, we are using the metals. We are using the tin and lead. Lead is the element which we are using for the fuse purpose. Okay. So, tin is using the coating of your brass metals. That is the tin is coated with a white color in the flourishing of shining of the nature. These are about the metals are used. This is about the carbon and that one. Now coming to the occurrence of the carbon. How can carbon can occur? What are the important minerals of the carbon? Can you see the important minerals of the carbons are hydrocarbons, petroleum, natural gas. The carbon can obtain in the nature itself as a coal, petroleum, natural gas is there. But this carbon is having of the tetravalency nature. It is having of the catenation properties there. What is the catenation property? The self-linkage among themselves is called as a catenation property. So only the property is present by this carbon atom. That's why the carbon is showing off. Due to the catenation property, it can represent as single bond between the carbon and carbon. It can represent as a double bond between the carbon and carbon. There is a chance of triple bond is present. There is a chance of whatever this is. It is nothing but what? Hexagonal ring structure. Cyclic hexagonal ring structure like this. It is nothing but benzene. Okay. Carbon can showing off single bond, double bond, triple bond, cyclic nature. Okay. This property can exist only for the carbon atom. That's why it is a tetravalency. Compulsory in any organic compound. Carbon is showing off the tetravalency nature. And this particularly carbon can exist as not only the catenation property, it can form the allotropes. Allotropes of the carbons are, you are having of the crystalline allotropes is there, amorphous allotropes are there. Crystalline allotropes are diamond, graphite, Buckminster fullerene. These are the, you are having of the crystalline allotropes. And amorphous allotropes are coke. Okay, lamp black. So what is the lamp black, sir? If you olden days, the household purpose without having of the electricity, they put as a lamp with the help of the kerosene or help of the any other metal, mustard oil or castor oil. They keeping in the one shelf. If you are lighting of that lamp, a black coated will be present on the wall. That is called as a lamp black. You are using of the surma, whatever you are katuka, applying of the ladies with it. There is nothing but the lamp black. Coke means pure charcoal, pure carbon, not drinking coke. Okay, it is not a soft drink. Coke means pure carbon atom cell. It is used in the industry purpose for the furnaces. These are all are amorphous. Amorphous means there is a powdered form. Sugar charcoal. When you burn the sugar, you are getting of the char. That is called as a amorphous charcoal. These are all are the allotropes of the carbon only. They are existing of carbon can form this type of nature. That's why the carbon is a very important metal which are aging. Coming to the silica. How can you get the silicon? The silicon, Si is called as a silicon. From this one, how can you get the silicon? Silicon can get when the SiO2. This is called as silica. Silica means sand. When the sand is combustion, that means you are reduction with the carbon atom. The silica is reduction with the carbon atom, you are getting of silicon. Simple. That means treated with the carbon, charcoal. We are using of coke. We are burning of the silica. We are getting of silicon. Si is called as silicon. SiO2 is called as a silica. Okay. Like lead, you are having also, this also from the galena, you can prepare the lead element also. But the mostly important is the two elements. Okay. So friends, this is about the fourth group elements. Importance is given as that one. Next, we will go to discussing about the what are the hydrides and oxides. Every group you can discussing of the hydrides and the oxides. Now coming to the hydrides. Carbon hydrides are, you know the familiar of the carbon hydrides. What are the hydrides? That is called as hydrocarbons are. The hydrocarbons are CnH2n plus 2 alkenes. CnH2n minus 2. Cn, this is alkene. This is CnH2n minus 2 alkynes. These are the hydrides of the carbon. We are getting tetravals. What about the silicon hydride? SiH4, germanium hydride, tin hydride, lead hydride, that is stannous hydride. Like that, you are getting off. All are getting off. Suppose in this case, we are using of the best example is methane. It is silane, germane, tinane, leadane. That means we can write as a SiH4 or germanium H4. Like that, the hydrides are formed. Just like the carbon atom, they can also form the hydrides of the remaining other. Plumbane, tinane, all are tetrahedral structures only. All hydrides of the fourth A group elements are just like this type of structures are present. All are tetrahedral structure. Coming to the oxides. What type of oxides are formed? It is an important one, the oxides here. The oxides are, we are having of two categories, monoxides and dioxides. So what is a monoxide means? Carbon is incomplete combustion. When the carbon is incompletely combustion means presence of oxygen. You are getting off incompletely combustion, you are getting off the carbon monoxide. The carbon monoxide is present. When you are burning up the fuel in your vehicle, that is incompletely combustion only. Emitting of the smoke is nothing but the carbon monoxide. This carbon monoxide is emitting into the atmosphere. This is a primary air pollutant which is emitted into the atmosphere. This primary air pollutant of the carbon monoxide is reacted with the oxygen which is present in the atmosphere. Formation of carbon dioxide. Carbon dioxide is a secondary air pollutant. Secondary air pollutant is not harmful than the primary air pollutant. That means this primary air pollutant is very, very dangerous to our human beings, living organisms. This is called as a carbon monoxide, which is emitted by your fuel. That means combustion of your vehicles. That means tons of the fuel is today you are combustioning by running of the vehicles. That you are emitting the primary air pollutant. It is nothing but incomplete combustion. So you are getting of this particular silica. This is carbon monoxide of the carbon. Like that, silicon monoxide. How can you get silicon monoxide means? Silica. When the silica is again treated with the silicon in silent electric arc, you're getting off SiO plus silica is formed. SiO and the silica is formed. Sometimes this SiO, actually this SiO, you're getting off, this is a unstable compound. Does not exist for few seconds. That means silicon monoxide does not form properly. When it is getting off, when the silica is treated with the silicon in electric discharge tube, you are not a very high temperature. The temperature is requiring of here very huge amount of temperature is required. 1300. Why? Because it is a very hard material. 1300 degrees Celsius. At this temperature, silicon monoxide is formed, but it is very unstable. Mainly important is the monoxides of the carbon monoxide. Now coming to the dioxides. How the dioxides are formed means when the carbon is completely combusted. How, sir? Means when you are cooking your food with the help of your what? Wood. Previously, olden days, the wood is used for the burning of cooking purpose. So that is nothing but the carbon. When carbon is completely combusted, what you get lost? Ash is obtained. Ash is getting. So the getting of completely carbon dioxide is formed. This is a secondary pollutant. So secondary pollutant is formed when the complete combustion of the carbon, you are getting of carbon dioxide. Similar manner, silicon dioxide also, when the silica is completely combustion with the oxygen, formation of silicon dioxide. See, here are the very important dioxides. Carbon dioxide. Where you use carbon dioxide? You are familiar with the carbon dioxide now? Our respiration purpose. We are inhaling, taking the oxygen from the atmosphere and releasing the carbon dioxide outside. That carbon dioxide is taken by the plant in the photosynthesis purpose. That means in the chlorophyll and also sunlight. In the presence of sunlight, that particular carbon dioxide is prepare the food for the plant and it is liberating the oxygen. It is going on. Then only the living organism is surviving on the earth planet. It is a process. It is called as a photosynthesis. The carbon dioxide is where again you are using of the carbon dioxide. That is nothing but using of the what? Aerated water. Are you drink the aerated water anytime? Anybody?
Yes,
Everyone. That aerated water is nothing but your soft drink. Pepsi, Coke, Limca, Thumbs Up, whatever that is called as aerated water. What is that aerated water? Sugar water is dissolved in the carbon dioxide. Nothing but. Some chemicals are there. Which flavor you want? Thumbs Up is some chemical. There is some chemical you can't say. It is some fertilizer, pesticide. I can say that it is a pesticide. The pesticide is added for the flavor purpose and sugar is added and some carbon dioxide is added. So you are drinking very nicely with the soft drink. Then you are liberating the carbon dioxide. After drinking of the soft drink, what happened immediately? Wow. That is nothing but the carbon dioxide is released out. Okay. This carbon dioxide is acidic in nature. Carbon dioxide is acidic in nature and silicon dioxide is also acidic. Please remember these two are acids. Carbon dioxide as well as silicon dioxide is acids, not a basic nature. So don't drink always a soft drinks. It is very dangerous to our health. Carbon dioxide is already you are emitting out. You don't want the carbon dioxide. Why you are taking in the soft drinks carbon dioxide? That is a very limited carbon dioxide. Now coming to this one. Here the question is in our examination point of view. Both are acidic nature, but the carbon dioxide is it liquid or gas? Carbon dioxide is a gas only. Okay. What about the silica? Sand. Is it liquid or gas or solid?
solid.
It is a solid. Okay. Carbon dioxide is a gas. Silicon dioxide is a solid in nature. Why? The question is, every time the question is asking. Why the carbon dioxide is a gas? Even though it is a dioxide of your fourth year group elements. When completely combustion of your whatever the element, you are getting out the dioxide. Carbon completely combustion, you are getting carbon dioxide. Silica completely combustion, you are getting of silicon dioxide. Both are acidic, but the carbon dioxide is a gas at room temperature, but silicon dioxide is a solid at room temperature. Why it is says? Because of the carbon dioxide is a linear structure. I will show that one. It is a linear structure. The carbon dioxide, we are using of the carbon dioxide is linear structure. It is a linear structure making of the bond angle is 180 degrees. So it is a at room temperature it is gas. But silicon dioxide, it is not a linear structure. It is a silicon dioxide is tetrahedral structure. It is tetrahedral structure only. Due to the tetrahedral structure, it is a solid. How it is tetrahedral structure, sir? Means every time structure of silicon dioxide is asking. If suppose not asking the why the carbon dioxide is gas, why not the silicon dioxide is? Because of, if you see, this is the silica. Okay. See friends, you are having of the SiO2. These are the bonds which are present in the, again, a gained molecule which is present. The gained molecule which are having of that one. So you are using of this particular silica which is present in this one. Again, this silica. Sorry. We are having of the silica structure. Okay. That will be represented in the oxygen bond, just like the in between the Si. This is a tetrahedral structure. This is a tetrahedral structure. These bonds are there. These bonds are there. Okay. This is the structure of silicon dioxide, but the carbon dioxide structure is linear. Due to of the linear structure, a double bond between the carbon and oxygen is present, so that it is a gas in nature. But silicon dioxide is a gained molecule. That is a giant molecule. It is a big structure. It is multiple. Again, the bonds are open. You can draw the structures every time. The silica is going on like that. So in between is a molecules are linked with this particular oxygens, so that we are getting of these silica dioxide again linked with the silica molecules. It is a giant like structure. It is a tetrahedral nature. That's why the silicon dioxide is a solid in nature. So solid in nature is particularly this particular carbon dioxide. Okay, silicon dioxide is a solid nature. But sometimes carbon dioxide is gas. But solid carbon dioxide is also called as what? Solid carbon dioxide. What is solid carbon dioxide? It is called as solid carbon dioxide is called as dry ice. It is also remember. If you see any functions, some cups we are keeping of the water, they are using of this solid carbon dioxide. Fumes are coming outside. Fumes are getting. This is nothing but the solid carbon dioxide, which is used as a refrigerant, cooling purpose, refrigerators, very fast cooling. They are used as solid carbon dioxide. The temperature is minus 80 degrees Celsius. When the gas of the carbon dioxide is cooling minus 80 degrees Celsius, you are getting of solid nature. That solid carbon dioxide is called as a dry ice. Both are carbon dioxides. That means both are acidic in nature only. So please remember, this is a very important point which are discussing in the fourth group elements are this one. Okay. Now these oxides are over, hydrates are over, and oxides. Hydrates are nothing is there, only just like the hydrocarbons, whatever the hydrocarbon. Say the fourth group elements also existing of the hydrates. That is a methane like that structure. The silicon, that is germanium, that is a SiO4. Okay, like that. But oxides are, dioxides are very important. Carbon dioxide, silicon dioxides are acidic in nature. Carbon dioxide at room temperature is gas, but the silicon dioxide room temperature is solid because of a giant molecule. But solid carbon dioxide, it is minus 80 degrees Celsius. It is called as a dry ice. Now coming to the special properties of this fourth group, carbides. What type of carbides are possible by the carbon atom? Why? Because the carbon is the essential element, is a very important element. They are showing off little bit extra properties, that is called as a carbides. So in your example, they will ask what is the carbides. So carbides are nothing but it's a binary compounds consisting of the carbon is different. The carbon element are present. Those are the binary compound which is consisting of that carbon is there. Carbides are differ the properties depending on the type of that one. Type of linkage. What type of linkage? Carbides are nothing but when simple, if you are using of the carbides, when you are using of the calcium carbide, silicon carbide, these are the carbides. We are saying the examples of calcium carbide. Yesterday I told that silicon carbide. That means this is a binary compound which is linked with this carbon is linked with the other metal atoms. Calcium carbide, silicon carbide, tungsten carbide, wolframite carbide. These are the carbides. So number of carbides are there. These carbides are binary compounds, and it is depending on the nature of the carbides. It is the properties are differ. So these carbides in this particularly carbon carbides are classified into ionic carbides and covalent carbides and metallic carbides. It is also for your examination point of view 10 marks question. Just to classify that one. So carbides are the binary compounds. Okay, these are the binary compounds of carbon, and these carbides are differ from the properties of different types. We are having binary compounds with the carbon atoms are there. Binary compounds. This is a binary. Binary means two elements. Okay, so ionic carbide, covalent carbon, metallic. Ionic already involved transfer of electrons. Covalent means sharing of electrons. Metallic means metallic nature. Only metals will be present in this one. So in this ionic carbide, we are having of the examples are aluminum carbide, Al4C3, calcium carbide. Okay, these are the examples of you are having of the magnesium carbide, beryllium carbide. All are belongs to these carbides only. So you are just like you are remember the few examples that will be helpful to the carbide. Means it is nothing but the transfer of electrons. Aluminum carbide. Suppose if you are using what is important means I will tell that one. Aluminum carbide. When the aluminum carbide is hydrolyzed, you are getting off methane. When calcium carbide is hydrolyzed, you are getting off acetylene. Yesterday you discussed. Okay, these beryllium carbide is hydrolyzed. We are getting off different compounds. Magnesium carbide. So these are called as aluminum. That means the ionic carbide. So this examples of the ionic carbides are aluminum carbide, calcium carbide, beryllium carbide, magnesium carbide. Coming to the covalent carbides, the covalent carbide is the example is silicon carbide. And we are having of beryllium. It is we are having of already beryllium is over. Boron carbide is there. V4C3. And metallic carbide is wolframite, tungsten carbide. The example of metallic carbide is wolframite. This is an example which are present in the carbide's nature. That means it is a binary compounds with a carbon. So depending on the nature of the carbides, it is the properties are differs. See, simple these two carbides when hydrolyzed, you are getting of the hydrocarbons. But these two are these carbides hydrolyzed, you are getting of different compounds, not the hydrocarbons. Only these two are getting of the hydrocarbons only. Okay, like just like the covalent carbides, it is a silicon carbide. This is a very giant molecule. Again, the silicon carbide. Okay, it is a very strong molecule you are getting of. Metallic carbide, there is a wolframite carbide. It's a very, very strong. That means tungsten, the filament which is used in the bulbs, that is tungsten. Why? Because the melting point of the tungsten is 3300 degrees Celsius. That's why you are using a melting, that is a filament in the bulbs. That value you are used in that one. Okay. So that is about the carbides. Now you go to the next one is the carbonyls. These are the important carbonyls are the carbon is having the showing of the carbonyl, mononuclear carbonyls, dinuclear. So there are two types are there, mononuclear binuclear. Mononuclear carbonyls, binuclear carbonyls. Okay. Mononuclear carbonyl is central atom is only one. Remaining ligands are present. Number of ligands are there. Those are called as mononuclear carbonyls. Binuclear means the central atom is two central atoms are present. Those are the binuclear. I will write the example of mononuclear. Nickel, tetracobalt C. Nickel is a central atom. Only one is there. The ligands are four are there. So it is linked with the four ligands are present on the central atom. That is called as a mononuclear ligand. or just like we are having of pentacarbonyl ferrate. This is a pentacarbonyl ferrate. It is a mononuclear. Okay, mononuclear carbonyl. Chromium hexacarbonyl. Please remember, it is also asking examination in the multiple choice question. Identify which is the mono, which is the bi. I can easily remember only mono means only single element is there. This is a metal. Single metals are present. Bi means, if you see the bi means manganese, Mn2, carbonyls, 12 carbonyls. See, 2 are there. This is called as a binuclear. Mn2, that is a 10 or 9, whatever you want. This one is a 10. And the next one is we are having of the ferrous carbonyl, Fe2, CO9. And one more is cobalt carbonyl, CO2, CO8. For your remaining purpose, I have used it as a 9, 8, 9, 10. These are the carbonyls which is linked with the bicarbonyls. Manganese, ferrous, cobalt. In the 3D black elements, right? Completely. After the 25th element, manganese, iron, cobalt is there. Here, nickel, ferrous, chromium. Okay? Chromium is 24th element. Ferrous is a 26th element. Nickel is a 27th element. These are all are present in the D black elements only. So these are the formation of the carbonyls are formed. Next is the silicates. The silicates also present in your case. The silicate pyrosilicates are there, chain silicates are there, cyclic silicates are there, sheet-like silicates are there. So silicones. From this silicates and silicones, these are the importance of silicates and silicones. The important questions in this, so many number of essay type questions are there. Just like the carbides is essay type question, carbonyls is a short answer, silicates is a essay type question again. These are 5 categories of the silicates are there. Silicones are different structural formulas are there. So those silicates with the help of the silicon only. This is about the 4th chapter. That is the we are having of the next. We have to take the 5th chapter. Already time up. Yeah, they giving the cautions also. So already 250. Okay, we'll leave that one. Any doubts tomorrow? You ask that one already. It's a 20 minutes over. Okay, friends. So tomorrow you can meet.